Hi, welcome to my class in mathematics modeling and simulation. And this course is made of 3 modules. The first module is matrix algebra. The second one is matrix calculus and applications to optimization. And the third one is differential equation. And this course different from the traditional mathematics class in these 2 aspects. First is application-oriented. In every module, we start with a real-world application, and then we slowly introduce the mathematics language. And secondly, we heavily depend on computational tools such as MATLAB and Stellar. I hope you're going to enjoy the class. This will move your knowledge in calculus to the real-world applications. Let's start from our first lesson of the first module, which is the application of matrix operation to population studies. And this content was originally developed by Drs. Angela Shiflett and George Shiflett. This nice application in population studies will connect the mathematics language to the real world content, and then you know the meaning of the matrix and the meaning of the operation. I hope this will help you. Let's start from the concept of data structure. Well, data structure is everywhere in computer science, and it is a formal skeleton, or say a frame that holds all the data and on which you can perform any mathematics operations. And today we're going to see 2 most frequently used data structure. One is vector, as a one-dimensional array in computer science language. Another concept is matrix, which is a 2-dimensional array. And those structure has a huge advantage to save you the trouble to name all the different variables in real-world application. Let's look at an example. And here is a data table. The table has 3 columns and 5 rows. And the meaningful column is the weight of the white tip reef shark, in short, WTS, and the other one is the weight of the black tip shark, in BTS. So we observed 6 months, and then altogether we have 12 numbers. Well, if you learned how to write a program, instead of give 12 different names for all those different numbers, it's much easier for you to claim 2 arrays. The first array, you call it WTS, then the first one is 0 all the way to 5, then you may claim an array like this. Depends on what language. That saves you the trouble to name each of them in each month. So you can do to the BTS like this. I use the MATLAB language. Okay, then see what operation we can do with those numbers. The first way we represent it is put into either an array of row vector, or alternatively, you can write it as an column vector. So it's the second one. The B we write into a column vector. It depends the language you are choosing. In MATLAB, you may call it W1, and then equals 20, W2 equals 6.7. But in C, you need to start from the W0 and to 5. Anyway, when we need to add the total weight of the two types of sharks in each month, all we need is add the two vectors. And you add the first month of WTS with the first month BTS, then you get the total 35 pound or 100 pound. What the units are, I don't know. And then you add the second month in the same way, and that's how you add the two vectors. Probably that's too easy. Let's move forward. And next, let's look at the second operation, dot product. And look at the example 3. If we want to predict the total eggs of this Hawaii green sea turtles, and consider the life cycle of the turtle in 2 stages. One, we call it novice breeders, and another one is mature breeders. The novice breeder lays 280 eggs, and then the mature breeder lays 70. Now we use a vector E to represent it. In printed book, they either use a bold face or you put an arrow on the top to distinguish the vector from scalar, like the 70. And if we assume you have 291 novice breeders and 9,483 of mature breeders. Now, how do you calculate the total eggs laid by both breeders? That's an operation. You know, you are going to multiply the number of the novice breeders to the eggs they laid, add the total of mature breeders to the eggs they laid, and together, of course, is the total eggs laid by both turtles. Well, this operation with respect to the two vectors, we call it a dot product because it is in the middle, you have a dot in the mathematics language. You see the answer is scalar. So sometimes this product, we also call it as a scalar product. Okay, that's fairly easy. We generalize this idea by giving the definition below. A dot product of two vectors In the first place, the two vectors must have the same number of elements. We call it the same length, which is n. You see x1, x2, xn. In the previous example, our n equal 2. And then the product of the two vectors equals the first element times the first plus second times the second, so on and so forth to the last times the last. Can you see it? You must have the same number of elements.